Greetings. This is our Unit 5 review. It's a few pages, but it's worth it, okay? Put your name and number at the top, please. Normally I try to leave some room for you to do a lot of these on your own, but this is what I would like to recommend as you go through here with me. Uh, if I get to a question and you feel very good about it, pause the video, do it on your own, and then skip ahead in the video. The video is going to be a little long. If you want to listen to all of it, of course, do it. Listen to it as many times as you want. Rewind it as many times as you want. You can even change the speed of the video if you click the little gear icon. But use my help as much as you need it, okay? In this first bit, we're looking at geoboards. You're going to construct each figure described below on your geoboard and then make a sketch of your work. Okay? So it says you're going to make a right angle somewhere on this geoboard. Okay? So as I look at this geoboard, I think to myself, well, I mean, I know most of the time when I think right angle, and I'll maybe just isolate this box here to make it a little easier to see, is when I think geoboard, I regularly think something like, well, I know that right angles look something like that. They have to meet at 90 degrees. It has to be perpendicular. But you could have one that looks like this. You could have one that looks like this. You could have one that looks like this. All right? So there's lots of ways you can build a right angle. How do you want to make it on your geoboard? And I'm going to make a bunch of them. Well, maybe not a bunch, but several. Because you could do the entire side. I could go all the way down one side and across the other. Those lines are perpendicular, so this is a right angle. Okay? Doesn't have to be that big. Maybe in green I'll isolate maybe a little bit smaller one. So maybe I just do, one that's 4 dots long and then 4 tall. But those are perpendicular, so I know that that is a right angle there. But it says not just a right angle, that it needs to be a right triangle. So what can I do to make my red a triangle or my green a triangle? Well, I should be able to just fill in the only missing side, and now I have a right triangle because it has one right angle. Acute right. What about my green triangle? Yeah, if I just fill in the missing side, I have 2 of the 3 sides, I now have a gorgeous right triangle. Acute angle, there's my right angle because it meets at 90 degrees. That's the nice part about the geoboard is these dots move in a nice pattern where the ups and the overs all make right angles. We have really nice 45-degree angles if you go 1 dot up, 1 dot over, right? Those are nice 45-degree angles. So geoboards are really handy. Ooh, and acute triangle. Oh, goodness. Well, that we cannot have a right angle. So that means we have to make sure that whatever we do, regardless of where our first line is, that the rest of it move in an angle. So what if I'm going to copy this bottom line here, okay? And I'm going to just go all the way across, okay? And now I can't have a straight up because that makes a right angle. And I can't have one here either because if I go straight up, that also makes a right angle. We don't want that. So what if I just do 1 dot over, maybe like I'm going to move in this direction. That's fine. That's an acute angle. But we have to make sure that wherever we go, this next, let's say the next angle, the side that comes off of this, also needs to be acute in a similar way. And if I want to, I could do exactly the same thing on this side. See how this, if I go 1 dot up, 1 dot over, and I follow this line here, and I do the same thing here, 1 dot, 1 dot, they're eventually going to meet right here. So let's do that. Just going to connect the dots here. And now I have my, wait, oh no. Did I, or did I not? That looks like a right triangle. I better do a little measurement there. Get out my protractor. Oh no, I just made a right triangle. So that doesn't work. Darn, that's no bueno. So what I need to do there, which would probably be a little bit helpful, is if I took that side maybe all the way up here. So if I make my green go here, and then I go here, now I'm going to have an acute triangle. I know it's kind of annoying to have that extra line there, but notice that it's helpful to play around, because as you're making them, you can find out, okay, that's acute, that's acute, that's acute, or in our case, when I drew this here, I accidentally made a right angle at the top. Bummer. Should have thought more about that before I drew that line. That's why you should use pencil. If it weren't so shiny, I would use it on these videos. A quadrilateral, that means 4 sides, with 1 pair of parallel lines. A quadrilateral, so it has to have 4 sides, and it has 1 pair of parallel lines, so like the opposite sides are going to be parallel. Okay? Well, let's just do that. Let's do opposite sides. I'm going to just kind of maybe just draw something like this. I'm going to make some parallel sides like this. Now I'm gonna look at it before I do anything else. So if I were to connect these dots here, I'd have a quadrilateral. These sides are parallel, they move in the same direction, they'll never touch. But if I were to do this, these sides would be parallel too. And we can't have 2 sets of parallel sides, it says 1 set of parallel lines. So what do? Maybe I do one of these. Okay, now I have 3 sides. How do I guarantee that this side here doesn't move parallel to this line? Well, you know, what if I just make this side longer and then connect the dots? Now I know that this shape, like if I follow this line here and I were to keep going, eventually it would run into this line. So I know that they are not parallel. So how many sides do I have? 1, 2, 3, 4. 1 set of sides is parallel, and then these are not. That's done. Oh, this says to draw 2 parallel lines. So you just pick a direction. Maybe we go across, and I do this, and then you can do all sorts of things to draw something that's parallel to this. I could do, this is a parallel line. This is a parallel line. This is parallel. All of those are parallel. They all move in the same direction. They would never touch. Okay? They are parallel to each other. It just says 2 parallel lines, but I did a little extra. 2 perpendicular lines. We know that perpendicular lines, wow, it's like really far up there. That's okay. And the geoboard's really low. That's kind of weird. I don't like that. Anywho, 2 perpendicular lines. They have to intersect at 90 degrees. Whenever I think perpendicular lines, I always think just 2 lines that cross each other perfectly. Because if one goes straight up and one goes straight across, there's no angles, like one's not crooked at all, straight up, straight down, straight across, we know that this is 90 degrees. Those are perpendicular. Now the fun part is that we know that this is 90 degrees, this is 90 degrees, and this is 90 degrees. It has to be, because of the way they intersect. So these are perpendicular lines. However, just for fun, look at this. Those 2 lines are also perpendicular. They meet at 90 degrees. They touch, they don't cross, but they are perpendicular to each other. They form a 90-degree angle. Oh, a hexagon. This will be interesting. A hexagon has 6 sides. You can do it however you want. Like I could go 1, 2, 3, 4, 5, 6. Now my hexagon looks kind of interesting, but it is a hexagon. 1, 2, 3, 4, 5, 6 sides. I just kind of just draw until I run out of numbers. So the way I usually do it, like if I need 6 sides, I'll just go 1, 2, 3, 4, 5, and then wherever the last 2 dots are, I just connect them. I don't care where they are. Okay? So if you were doing an octagon, same idea. You would just draw as many sides as you can, try to make sure it avoids your starting point, and then when you get to line 7, you just connect the last 2 dots and you're good to go. Alright, you're going to use your protractor to measure this angle. Okay, got my protractor. I set it on here. I got to line up that center with the vertex where the two lines meet. Okay, and then this black line that goes all the way across the bottom has to be flat against the bottom of the angle. So I try to line it up perfectly so that that lines up. So we have a 0, and then I count up, and I figure out what this is. Now this appears to be between 70 and 80. So what's between 70 and 80? Well, probably 75. Okay, we'll call that good. Sketch an angle that measures 60 degrees. Well, let's start with a flat line because that's awesome. Okay. 60 degrees. If we're going to do 60 degrees, let's count up. So I'm going to line up that center. Make sure it's flat. Make sure that I have a nice 0. Count up from the 0 to 60. 10, 20, 30, 40, 50, 60. Mark where that 60 is. And then finish your line. That is 60 degrees. Woo! Now what's Ed doing down here? Ed sketched a straight angle. So there's a straight line along the bottom. Then he divided his straight angle into 2 smaller angles. I think that's supposed to go all the way down. Just so you know, it's not that big of a deal, but it bothers me a little bit. So he's got an angle B and an angle C. So we're going to determine what C is based on this. Well, tell me, this straight angle, the whole thing, is 180 degrees. That's what a straight angle is. He started by drawing a straight angle. Straight line. Anytime you draw a straight line, it's 180 degrees. And then he drew this line here and split it up. This side is 65 from here to here. So we need to know what's over on this side. Interesting, interesting. So we need to figure out what's left. You could think of it as a number line, right? You could say, well, I was measuring at 0, and then my angle got to 65. We're trying to go all the way to 180. So what is this distance right here? That could be the way you're thinking of it. And you count from 65 and you go up to figure out what that number is. You could also stack and subtract. You could say 180 minus 65. Okay? But I'm going to let you choose whatever strategy you would like to figure out what this missing angle is here. Straight line's 180. They made this angle here, so this is 65. So we're taking 65 away from 180 to figure out what this angle is here. Okay? Go for it. Pause this video. Nail it. You got this. Oh, Bob sorted a collection of shapes and labeled them. This looks familiar. Take a good look at his work and answer the questions below. So it looks like he's got shapes with 2 pairs of parallel sides. So this side's parallel, that sort of thing, right? Actually, those are the wrong marks. Those should be arrows, but that's okay. Okay, so all of these have 2 sets of parallel sides. At least one obtuse angle, so that means bigger than 90, so that's obtuse, obtuse, no, that's acute, obtuse, that one's acute, that one's obtuse, that one's 90, that's obtuse, okay. And then this looks like a blend of both, so that's fun. So do we agree with labels Bob wrote for each group? That's the first question. 2 pairs of parallel sides, 2 pairs of parallel sides, 2 pairs of parallel sides. That does look parallel. These look parallel. Those look parallel. Those look parallel. Okay, so far I like it. At least one obtuse. And then these are these 2 angles. These are obtuse. These are obtuse. Yeah, so I do agree. Why? Because he sorted them based on parallel sides and obtuse angles. Why are there 2 shapes in the middle where the groups overlap? Well, because these 2 shapes are both. Bob says he can't put a right triangle in either of the groups. Do you agree or disagree? So a right triangle would have a 90-degree angle an acute angle, and an acute angle. Oh, so there's no obtuse angles in an acute triangle, so it would not fit in this side. Two pairs of parallel sides, and no sides of a triangle can be parallel. So I do agree with Bob for the reason I just said. And then grab your colors when you have a second. Find all the quadrilaterals that are not parallelograms, color them red. Find the trapezoids, circle them blue. Find all the parallelograms and color them green. Don't forget, so I really do think that you guys have a stellar workbook page. And I'm just going to bring it up real quick. I don't like to take too much time, but I mean, it's such a nice resource to have. So I'm just going to bring it up so that you can, in the future, use it. Now, unfortunately, I wrote on the previous page in Sharpie, and so it kind of bled through my page. But page 187 has all the things. Triangle, quadrilateral, pentagon, hexagon, octagon. All the triangles, scalene, isosceles, equilateral, right. And then down here, this is where all the good stuff has. These are all quadrilaterals, but they've grouped them into trapezoids, parallelograms, rhombus, rectangle, square. And you're trying to identify parallelograms in this question. A quadrilateral with two pairs of parallel sides, the same length. The same length. Okay? So a rhombus has all four sides the same length. We often think of the parallelogram would be like a rectangle that you kind of squish or twist to the side, leans over, right? So as you go through this one and you're looking for the parallelograms, keep those definitions in your head. Don't be afraid to look at those book pages, or if you've been writing them, some of those definitions in your math notebook or handbook, that works out too. Last page, let's do this. Use this rectangle to answer the questions below. So it's 5 inches tall, 34 inches wide, or we could say wide, width and length if you want to. Which formula shows how to find the area of this rectangle? Well, we know that area is length times width, correct? Area is equals length times width. It's got to be that. So now find the area. So now that we know that area is length times width, let's actually take length times width, and let's take 34 times 5. Okay? Zoom in a little bit to make this easier to follow. By the way, if you know how to do this, then just pause the video and do it. 5 times 4 is 20. Carry the 2. 5 times 3 is 15. 15 plus 2, 17. So my answer is 170 what? Well, our units are inches. We're finding area, so it has to be square inches, which is what I was supposed to write there, but you could write it in the box. Now we're going to look at this rectangle to answer the questions below. 23 centimeters by 130 centimeters. Good rectangle. Which formula shows how to find the perimeter of this rectangle? Is it a length plus a width? 2 times the width plus 2 times the length? 3 times the width plus 3 times the length. Wow. A lot going on there. Well, we know that there are 2 23s and there are 2 130s. And to find the perimeter, we go all the way around and add up all the sides. So there's 2 23s and 2 130s. So there's 2 widths and 2 lengths. You add them together. Perimeter is when you double the width, double the length, add them together. Does that make sense as you look at this rectangle? Double the width, double the length, add them together. So if you actually do that, double the width would be 23 plus 23, that's 46. And then double the length, 130 plus 130 is 260. And then I add them together. Okay, that's exactly what this says. Double the width, double the length, add them together. That's for finding the perimeter of a rectangle and technically a square. Okay, and then you're going to write your answer down here. Okay, thank you for your time. I hope this is helpful. Like I said before, it's really nice to be able to take these questions, try them on your own first. Go back and watch the video. And if you nailed it, great. You're probably going to be ready for the test. If you weren't sure how to start the problem, no worries. Just follow along. Try to do as much of it as you can. And then use the video to check your work. Okay? I will check you guys later.